Okay, today we're going to review the states of matter, and this is for Mr. Reyes' 7th grade science class. And the first thing we talked about in class, and this is on your states of matter review sheet, assignment number 6, is that we define matter as anything that has mass and takes up space, which means it has volume. All right. Then in class I had you try on your own to list the different forms or the different states of matter, and almost everybody came up with the common three, which are solid, liquid, and gas. And then we talked about together that there are actually two more states, and those are plasma and Bose Einstein. And we talked a little bit in class about a plasma is something where it's superheated, the electrons and the atoms are moving super fast because they have a ton of energy, and examples of plasmas are lightning, the material that makes up stars, our sun, neon and fluorescent lighting. Those are all examples of materials that are made of plasma. And then the opposite of a plasma is the Bose-Einstein state, and that's when the material is so cold that the atomic motion or the molecular motion stops. So the electrons that spin around the nucleus of an atom stop spinning, and everything basically freezes. And we talked in class about how those materials, those atoms, actually kind of join together and melt together in a cold way and produce this frozen blob, which is kind of cool. We're not worried about those two states as we move forward, but I did just want to point those out to you. So moving on to the three major states that we deal with, solid, liquid, and gas. If we look at your sheet today in class, we started to talk about a solid. And so we said a solid has two very specific characteristics, and this is what separates a solid from a liquid and a gas. And that is, a solid has a definite shape and a definite volume. And this is because the molecules inside the solid, they're packed very tightly in a fixed position. All right. We drew the molecules in class, and we drew them. All right. Sorry for that interruption. I don't know if you heard Mr. Mansfield come in, but we were saying that solids, the molecules are packed in a fixed position, and they're arranged in a specific pattern. And again, I drew them, and we drew them in class in rows and columns. But as they're in their fixed position, they don't move, but they do vibrate, and that's because they had energy, or they have energy. And so when we drew our molecules, we drew some of those little quotation marks around them to represent the fact that they were vibrating. All right. Now, as we move from state of matter 1, a solid, to number 2, a liquid, underneath the box on your sheet, what I'd like you to do is draw a couple more notes or add to the diagram. And that's because as we move from a solid to a liquid, we need to add something. And what we add is we add heat. And by adding heat, when we heat up the molecules, we're actually adding energy to them. And so when the molecules have more energy, they can break free of their fixed position, and they no longer vibrate, and they actually start to move around, which changes the material from a solid to a liquid. Now, if we can work backwards, if we come from a liquid to a solid, we're going to do just the opposite. We're going to decrease the heat or remove energy. And that's actually what you do when you, let me just go back, sorry. When you freeze something and you put it in the freezer, you're actually removing the energy, which slows down the molecular motion of the molecules, and they become fixed and just vibrate, and that's what turns something into a solid. Okay, but looking at a liquid, all right, the characteristics or the description that separates a liquid from a solid and a gas is that they do have a definite volume, all right, so they take up a specific space, but they do not have a definite shape. And what liquids do is they take the shape of their container. So whatever container you put a liquid in, it's going to take the shape of that container or try to fill that container the best it can. All right. The molecules are still close together, but they're not in a fixed position. They are moving, and actually I say they're sliding freely past each other. They kind of slide in and out and around of each other. So in your diagram, again, you should have a decent number of molecules drawn. Kind of have them spread out a little more than you do for a solid. And instead of drawing those little quotation marks to make it look like they're vibrating, we're just going to draw some random arrows that show that the molecules kind of move in and around each other, all right, and slide past each other, which makes them behave in a liquid. And then again, as we move from a liquid to a gas in number 3, again, in order to change a liquid to a gas, we increase the heat, which means we're adding the energy. And if we want to work backwards from a gas to a liquid, we're going to decrease the heat, which means remove the energy. Okay? And then the last state of matter that we want to talk about is a gas. And the two characteristics of a gas that separate it are gases have no definite volume or no definite shape. Right? The molecules will spread out, and this is why they say they have no shape. They're going to spread out as far as they can to fill whatever container they're in. So if it's helium and it's in a helium tank, those helium molecules are going to move around and spread out as far as they can to fill that container. In our classroom, we have a lot of different gases in our room, and those gases spread out as far as they can to fill this whole classroom. All right. The molecules in a gas, they move freely and they move extremely fast. And a majority of the time they're moving so fast and so randomly that they bump into each other and they bump into the sides of a container. And that's how actually a balloon is blown up. When you blow up a balloon with helium or your own hot air, it's just gas inside, and what keeps the balloon firm and you can, press on it is the molecules. The gas molecules are trying to get out, and they're hitting the sides, and they hit them so fast that they make it feel like there's a substance inside of it. So for your diagram, you want to draw just a few molecules, and again, you want to draw arrows that show that they're moving all around in all different directions. You can draw some of the arrows so that they're bumping into each other or bumping into the sides of their container. All right. So hopefully you got all those notes, and a majority of it is review from last year, and so that you feel pretty comfortable with talking about these states so that we can move forward to our next topic, which is how is the heat transferred from these materials. So how do we heat these things up? And that's what we want to look at next.